All right, so this is the area of shaded regions. And remember, I told you when we started the area stuff that really the basic area is not even part of high school geometry. High school geometry is more, as far as area is concerned, two-dimensional area, is composite figures, putting them together, taking them apart, and not just looking at one individually by itself. And so we've reviewed a bunch of the basic area stuff that you have already learned, added just two new things, an area formula that works for rhombus and kite, and one that works for regular polygons. Everything else was 100% review. So this says find the area of each shaded region. All answers should be in exact form. Assume all polygons are regular. Now, I really should have said assume all polygons are regular unless they clearly are not. Number 3. Look at the triangle in number 3. Is the triangle a regular triangle? No, that's not what I mean by assume that they're regular. It's assume that, like, this doesn't say it's a regular hexagon, but it's a regular hexagon. Okay, so there's like two things on there that clearly not regular because of the way they're labeled. But if you're thinking, ooh, I wonder if it is, it probably is, then it is. All right, and so we're going to do number 2 together, and we are going to start. Each one of these has to have a plan. Sorry, lost my train of thought there for a second. Each one of these has to have a plan, and that's, you have to start all of them with that. That is something that I am looking for. Your plan does not have to look exactly like mine. It doesn't have to look exactly like your neighbor's. But if anybody were to walk up and look at your paper and see your plan, they should be able to make sense of it and be able to follow it themselves. Because sometimes there's more than one way to get to an end result, and that's fine. But there has to be a plan. That's one of the things I'm looking for. You don't have a plan, chances are pretty good I'm not even going to look at the rest of the problem. Okay? So if we're gonna do number 2 together. So on number 2, who thinks they could give me what a good plan to find the area of the shaded region would be? Anybody? What could we do? Park? Okay, fine. Or you could just tell me, like, we don't have to draw pictures, but like I would find what and do what with it. Okay, subtract what from what? Circle from, so it'll be hexagon minus circle? Yeah, it'll be what? Circle minus hexagon, right? Okay, we agree with that? All right, can anybody give me a different way to do it? That's the way that's the way I think is the best way to do it, and that's the way we're going to do it, but is there another way to do it? There is. Let me see what that is. Okay. So I'm going to show you, I'm going to draw it on here, but don't draw it because I'm going to then erase it because it's not really the best way to do it, but it is how some people see this. I mean, yes, it is a hexagon that's inscribed in a circle, but I could make this into a sector, right? And so remember how we could find a sector and then we took out the area of the triangle to get this piece. What was this piece called? Segment, okay? So do you see how I can find the area of the segment and then do what with it? Multiply by 6. So that works too. It's like a completely different way to look at it and a completely different way to work it, but it works, right? Just a different way to do it. But circle minus hexagon is totally how we're going to go. So my plan, which I'm going to write down first, is going to be circle minus hexagon. And whether you do pictures or you have words or whatever, then you need to have, I mean, you don't have to draw the picture. You can write the word circle, but it needs to be something that clearly is, this is my plan to get going. Okay, we good on that? All right. So then you go forth and do what you need to do to find your stuff. So the area of the circle, what's the area of a circle formula? R squared. Okay, what's the radius? 16. 16 squared. What's 16 squared? Remember, you should know your perfect square is 25. This shouldn't even take you more than 1 second. 256. 256 pi. Whether you put the units here or not, it doesn't matter because we're not done. But you do need to kind of highlight that that's an important part of your answer somehow. If you have nice, neat, organized work, then it shouldn't be difficult for you to find. We don't all have nice, neat, organized work. And that's okay. That's something that's at this point in your life is kind of hard to fix. But you do need to have some way then in your crazy mess of work to be able to find this. What the heck are you doing, dude? When does that do? You're doing it in class, yeah. And you're doing anything on it now? Then you need to get it. Okay. So now we're going to find the area of the hexagon. So the hexagon is a regular polygon. So remember the area of a regular polygon. What's your formula for that? Base times height. Y'all agree with that? A and perimeter. Okay, good. So it's 1/2 apothem times perimeter. A hexagon does not have a base and a height. Oh, I put B because I was talking in, sorry, perimeter. That's what I meant to do. All right, so did they give me the apothem? No. Did they give me the perimeter? No. They would never give you the perimeter. So I have to find the perimeter. Perimeter is equal to n times s. What is n in this case? Which is specifically 6. Okay, good. Yes or no question. Did they give me the side length? No. So I'm going to pause right here. I'm going to come back to my picture. And I'm going to draw in at least 2 radii. One was already there, so we're going to have to draw the other one. Then I'm going to draw in my apothem. And I got to find my central angle. So 360 divided by 6 is what? 60. Okay. So then I take this whole triangle out of the picture and redraw it. Remember, the idea is to get it redrawn bigger so that you actually have a place to label stuff. This is 16, this is 16, because you always get an isosceles triangle. And since you always get an isosceles triangle, when you draw in the height, it always bisects the base. And this whole thing here is 60. All right. So if this whole angle is 60, what are these two? 30 and 30. So I'm only using this side of the triangle. Right? And what is this length right here? 8. And what's the apothem? 8 square root of 3. So when I go back to substitute in for perimeter, my side length, is it 8? No, it is 16. Because this is the whole side length, right, which is 16. That's why you should always take the entire triangle out, even though you're only using one little half of it. Because if you only take half of it out, I promise you, you will use the wrong number at some time. Now, before we even did this, did we really already know it was 16? Yes, because we knew it was an equilateral triangle. Does that happen in every polygon? No, it only happens in a hexagon, okay? In a regular hexagon, yes. So this is 6 times 16. All right, so then 6 times 10 is what? 60. 6 times 6 is 36, so that gives you 96. So there's my perimeter. So now I come back over here and substitute it in. 1/2 times the apothem, which is 8 square root of 3, times the perimeter, which is 96. So I could take half of the bigger number. That would give me 8 times, what, 48? I think I might like 4 times 96 better, right? So let me tell you how to think through something like that. 4 times 96, right? Well, 96 is how far from 100? 4, okay. So 196 is 4 from 100, right? If I multiply it by 2, then it's going to be 8 from 200. If I multiply it by 3, it's going to be 12 from 300. If I multiply it by 4, it's going to be how much? 16 from 400. So really all I have to do is 400 minus 16, and that's my answer. I'm not carrying my wand and doing anything else like that. Does that make sense? That's logic and reasoning through it. So what is 400 minus 16? 384. Okay, so this is the area of a polygon. More specifically, it's the area of the hexagon. So your little subscript could be hexagon or it could be polygon. It doesn't really matter. 384 and square root of 3. Right? We're all good so far? So here's this, and I have these two pieces. Now I have found both of the things in my plan. Okay, got that one, got that one. When you're done and you have found everything you need to find, you shouldn't have to think very hard about what to do next because you made your plan from the beginning. If you wait until the end to reason through what to do with it, sometimes when there's a lot of stuff going on, it's a little overwhelming, but you don't have to. You just go, okay, I found the two things, so now I know my area is whatever I got for the area of the circle, which is 256 pi, minus whatever I got for the hexagon, which is 384 square root of 3. Then you combine like terms if you can. Is there anything I can combine or reduce or anything? Nope. That's the best I can do. So parentheses and centimeters squared. If you wait until the end to decide whether or not you need to add or subtract and in what order, then you're also having these numbers facing you which can cause you to think about it wrong, right? Because 384 is bigger than 256, but that really means nothing, right? We good with that? All answers should be in exact form, so you don't need a calculator for any of this. All right, we good? All right. Got the basic idea? You have all the pieces, you just got to be able to put them together. I want to look, though, at number 6 real quick. It says, what is the ratio, blah, 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 blah. So when you see the word ratio in math, what should that make you think of? Fraction. So don't make this out to be harder than it is. It's asking you to set up a fraction. You can handle that. If you couldn't do this, I wouldn't give it to you. Okay? You can do this all 100% on your own, just fine. We good? Question? Alrighty.